who do not have any idea of design, I am developing the test bench. I know how to develop the test bench. That person told, see, the inputs are A and B, output is Y. That person called me, told me this, and tell me, please develop the test bench. I don't know how that person has given the code list. I given according to my choice. B comma, A comma, Y. I have given B comma, A comma, Y. See, same input, then output. Now, that person also has given input, then output. Is this correct? No. What will happen? This B port will connect with A port of design, which is not correct. This A port will connect with the B port, which is not correct, because the test bench will generate A. The value will go to B. So the truth table will become scrambled. Truth table will become scrambled. You will get the output. It is not like that if you give this one, you will get the output. But you will not able to analyze the output properly if you relate that with test bench. And if you give Y, B, A, then the entire thing will be down. Okay. So what is needed? Simple follow the rule. A comma, B comma, Y. First input, then inputs, then the output. Next one. Do you have any confusion about this instantiation? See, this will become a habit for you. Now you can think this is becoming a little bit complex one. That instantiation, what are the steps, will go to the home, will definitely forget. That is not a problem, because the same thing we are going to explain again. But when we start explaining now, when we come to the flow, that will be easier for you to understand that what I am telling you. What are the steps I will be doing here? Then you only tell me. At that time, you only tell me that this is this. Because in the session, what I do, I intentionally do some mistake. I stop and I tell what will happen. Is this correct? Is this entire thing is correct? You have to tell me, you have to detect that error and tell me, sir, this you need to change. This you need to change. Okay.
क्या करें ऑप्शन नहीं है.
Next one. Spellings generate. Okay. Initial beginning. I told you. Initial we are going to use in test bench. Always we are going to use in design. Because test bench is non-synthesizable. We are not going to convert the test bench into anything. We are going to convert design. This is a mobile. Okay. This is a mobile. Okay. Can you open the mobile, sir? Where is my test bench? Can you find test bench here? What you will find? Chips. You will find chips. Chips are what? Nothing but design. Design that has been written in Verilog after so many steps that has been inbuilt as a mobile. But you can't find any test bench. Test bench is used for verification. When verification is done, test bench is done. Okay. So test bench do not have any physical significance. That's why whatever non-synthesizable construct we are going to be using test bench. Next one is initial begin. What I told you, we are going to generate the inputs. Right? A equal to $. Equal to $. Now, this two line is same. Writing A equal to 0, B equal to 0, then A equal to 0, B equal to 1, then again A equal to 1, B equal to 0, then A equal to 1, B equal to 1. $random will do what? Generate random values. Random values. Actually, it will generate random value of 32 bit. Actually, it will generate random value of 32 bit. As my A and B size is 1 bit, only MSB it will take. Whatever value there in LSB, sorry, whatever value is there in LSB, it will take that. Because the LSB value will be either 0 or 1. LSB value will be either 0 or 1. Because that has been implemented in binary. 32 bit. Please understand this one. $random generates 32 bit value. For this case also it will generate 32 bit value. But what is the size of A? Single bit. A is single bit. I have generated 32 bit number. Okay. So whenever I am going to get the A will give you only single bit now. Because A can store only single bit. So which value A is going to store? The LSB. The LSB value of that 32 bit. LSB values can be either 0 or 1. So either 0 or 1 will go. Okay. Then give a hash 5. This is the way. Hash 5 means 5-second delay, everyone. Is it 5 seconds? VLSI do have any concept of second? VLSI have concept of nanosecond. Mostly the work is been done in nanosecond. That's why the tool also is been implemented like the or configured like the way that the default time is nanosecond for tool. So if I write hash 5 means 5 nanosecond delay. 5 nanosecond delay. Then we use $display. This $display is similar with printf. You have used in C, correct? Printf, scanf. Where we have used printf? C. Why? To print something, correct? Until and unless you print something, how you can tell that okay, this is working fine? Right? In C, what was really complex program? Fibonacci series. Right? Fibonacci series or factorial. So we used to display that one, correct? In the screen, so that we are getting the correct. So this is same in Verilog. $display. A equal to percentage B equal to percentage B by equal to percentage comma E comma B. Again, sir, it is not again for this $display. Instead of Y, you have to write like this. This is the rule. This is the syntax. Language always follow syntax and constructs and keywords. So if you tell me, sir, why this percentage B? Percentage B is the format specifier to display the value in binary. Percentage B is the format specifier to display the value in binary. Now next another question will come. Sir, I want to display this in hexadecimal. Then we need to give percentage H, hexadecimal. Sir, I need to print in octal, percentage of, in decimal, percentage D. Okay. String, percentage S. Now, this is single bit, correct? Will there be any difference if you display them in hexadecimal, octal, decimal? Will there be any difference? No, single bit means it will give you either 0 or 1. So 0 or 1, 0 and 1. There is no difference in binary, decimal, hexadecimal and octal. That's why I have used percentage B. I want to display them in binary. Then, the many format specifier you are using, those many arguments you have to do. This portion will tell you it is going to display the value of the variable A, B and Y. Inside this, I can write my name also. Can write your name? Suman. Your name? Savita. Okay. So how we will get the display? This will come equal the value. Actually matters this format specifier. This format specifier will print the value. We just give something inside that so that the display will be compact. We'll get the proper display. So A, the display will come like that. A equal to value, B equal to value, Y equal to value. The value depends on format specifier. The format specifier is connected with the input and output arguments. This completes a basic testament. Okay. Now this, what will do? It will generate only one time. It will generate the A, B value for one time. Because the characteristics of initial begin. Initial begin do not have any sensitivity list. So initial begin starts at 0 time, ends at 0 time. Okay. If anything that is starts at 0, ends at 0. Okay. So that will execute only one time. Basically or by default, that will execute for one time. Now, only generating one input, that will be sufficient to check whether my design is working fine or not. What I need to do? I need to generate more inputs. 4 input is okay, but whenever I am using $random, I don't know that whether for the first 4 time only all the combination will come. I can't tell that one. So I need to test for some condition, for some repetition. For that one, we have repeat is 30. This repeat will do what? This repeat will execute this initial begin block for 30 times. Repeat inside 30 begin. All these statements gets repeated for 30 times. Means I'll get 30 set of input. 30 set. Now out of 30, I can tell I'll get all the 4 combinations. The possibilities are high to get all the 4 combinations. So that completes the basic test. Please tell me if you have any concept-wise confusion. If you have, please tell me. If you are not able to remember, there is no problem. You please see and tell me. Concept-wise, if you have any confusion.
सुरक्षित मैं क्या बोल रहा हूँ उसको नीचे रख दो.
Why you use dollar?
जब तक तो पढ़ने को यार मेरे को ना वो रिकॉर्डिंग करना देखो एक अब सुअर मत कर.
$random. Yeah, $random will do what?
रिकॉर्डिंग चल रहा है इधर देख इधर.
Generate A and B value automatically.
अब मैं पढ़ूंगा कैसे बता.
Otherwise, if I don't use $random,
वो पढ़ा
otherwise what I
रिकॉर्डिंग
need
कर
to
रहा हूँ
write
मैं.
हाँ तो ऐसे ही रहेगा ना, सही है।
पढ़ूंगा किधर, लिखूंगा किधर,
Again,
माथे में।
equal to 1, equal to 0, b equal to 1. Equal to 1, b equal to 0. So we need to give hard-coded value. We need to give hard-coded value. For that, I need to write 8 lines, correct? 8 lines. Now I have 30 inputs. I have 30 inputs. How many lines you are able to write? You have 30 inputs. Okay. I want to generate all the possible combination of the inputs. How many lines you need to write here? 2 to the power 30. 2 to the power 30, not 60. 2 to the power 30. 30 inputs need to generate all the combination. What that 2 to the power 30? Are you able to write that one? Instead of that, if I use $random, I have to write only 30 lines for that one. The many inputs, the many $random will automatically generate the combination. What is $random? This is a system task. System task that is already there in the system. In the system, in the language. Whenever we write this $random, when the execution will come here, automatically the tool will generate some number with respect to A. We need not to give any number explicitly. Which one is easier, giving number explicitly or let the tool do the work? Let the tool do the work. We have that privilege to generate, the tool is going to generate the number. So let's take the privilege. Simple. Anything else? Dollar display. Exact. See, percentage B is format specifier. Format specifier means this will print the value according to the format specifier. Whatever format I am giving. Suppose, so this is single bit, correct? Suppose 20 got generated. 20 got generated. Okay. I have given the format specifier as percentage B. Percentage B for ball or binary, percentage B. Then how the display will come? 20 is over 16 plus 4. Okay. So 1 0, 1 0 0. 1 0 1 0 0. Yes or no? The display will come 1 0 1 0 0. If I give percentage D, that is decimal, the display will come as 20. Decimal 20. By default, it is 20. If I give percentage H, that is hexadecimal, then the display will come 1 0 1 0 0, correct? So 0 1 0 0. 0 1 0 0 is what? 8. No, 4. 4. So it will come as 14. 1 4. How to convert binary to hexadecimal? Okay, let's do this one. 20. 20 is what? 16 plus 4. No need to calculate in a complex manner. 20 is 16 plus 4. Break the value in 2 to the power format numbers. That is nothing but 16 plus 4. 16 plus 4. 16, I can represent 16 in 2 to the power format. Yes or no? I can represent 4 as 2 to the power format. 16 is what? 4. 2 to the power 4. Okay. That will be 1, 0, 8 is 0. 8 is not there. 8 is 0. 2 to the power 3 is not there. 0. 2 to the power 2 is there. 4. So 1. 2 to the power 1 is not there. 2 to the power 0 is not there. So 1 0 1 0 0. 20 in binary. Basic conversion. 20 in binary. Now if I tell convert 20 to hexadecimal, what you need to do? Hexa. Whenever this conversion will come to picture, simple thing. Take them to binary. Nothing else you need to do. Convert them to binary. Take 440. For hexa, take 440. So if I convert them as 440, this will come like this, right? Will remain with 0. So that will be 1. This is 4. So in hexa it will be 40. Tell me in octal.
अरे तो यार मम्मी क्या बात करते
Tell me
हो
now.
रूम में तो बाहर का भी तो खाना पीना लगता ही है ना जो घर में खा रहा हूँ बाहर आपके पैसे लगते हैं ना कौन देगा
घर में रोटी सब्जी खाना
वो बात सही है लेकिन अभी ये थोड़ा छोटा मोटा खाना रहता है
What will be the value? Convert 20 to octal. My question is that.
डेली का लगता है ये तो
3 4 sir.
बाहर का भी तो एक्स्ट्रा लगता है
Take 3 bits. Starting from LSB, take 3 bits. Fill that in 0. 1 0 0 is what? 1 0 0. 4. Why 2? 0 1 0 is 2. That is now coming here. If I tell my A value is 20, if I tell my A value is 20, Verilog default number system is decimal. Verilog default number system is decimal. If you write 1 0, it will take 10 in decimal, not 2 in binary. Okay. Now, if my question is, if A value is 20, this percentage B will display 1 0 1 0 0. Okay. Percentage D, if I give percentage D, the display will come as if I give percentage D, what will be the display? 20. My A value is 20. The default system is percentage D. So it will give me 20. If I give percentage H, what will be the display? 14 will come. If I give percentage O, then 24 will. Simple thing. Here, as all these 3 variables are single bit, that's why I am using percentage. So you need to remember percentage. All these things will explain again. Okay, we'll discuss regarding this one. Percentage B binary, percentage D decimal, percentage H hexadecimal, percentage O octal. You need not to convert explicit. Take some value, display them in different format specified, you will get the value. Understand? Okay. Tool will do this thing. Format specifier means it will specify the format. Format for what I can say that size, then the type actually. I forget the term. Yes. Here we are telling format specifier. It is specifying the format, data format. Okay. Normally there is one term. I just forget. If I can remember, I can. So, any more question? Any confusion? Here? You can write percentage B, percentage B, percentage. Yeah. You can write. But how the display will come?
अब ये रखा, अब ये मेरा बेल पे रखा, दो गिरे
Huh? But that will be good to display, or you are specifying the input and what is the value for that input is coming. That will be good to see as display. A equal to percentage is A equal to. This doesn't fall under the rule. A equal to I am giving for understanding, to get a understandable display. Okay. Then the many for then you need to understand the many format specified you are giving. Those many arguments should be here. Those many arguments should be here. It is not like that you have given A equal to percentage B, B equal to percentage B, Y equal to percentage B. Then you just give A comma B. You just forget to give Y. You will get an error. Error you will definitely get. Okay, anything else? Then the next part is to run the code. For that, what I am going to do? I'll open my models. When you install models in, okay, after installation completion, if you want to find, okay, search here. This search is here. Search is here. Right model. This will come. If you double click that or click that, your model sim will open. When your model sim will open, two possibilities are there. Either this transcript window will open. This is transcript window. Okay. This one is transcript window. Either this kind of window will open, or for me it is not opening, or one model sim window will open. This is the model sim window. If you are not able to, my question is that for some case or sometime, for the first user using first, maybe this transcript will not come. Maybe it is not like that it will not come. If it has come, then there is no problem, or you need not to worry about that. If you are not able to find this transcript, this blank transcript window, go to view option. You will see this transcript is not checked for your site. You have to check this one. You have to check this one. Okay. If you click this one, this option will get checked and your transcript will come. Next, in this transcript window, we are going to give all the commands to run a code. Okay. First command is CD. CD, I think you know. What is CD? Changing the directory. Changing the directory. I need to change the directory, right or wrong? Now, my tool, if I write PWD, means present working directory. If I write, it will point out to this. Means my tool is pointing out to this folder where it has been, the application is been saved. This is the default one. I need to change that one, correct? I need to give the direction to the tool where I have kept all my design and test bed file. Yes or no? Yes or no? We need to give the direction. How to give the direction? Simply change the direction. So write CD, flower bracket. You can tell second bracket, flower bracket. Actually this bracket. If you are not able to see this bracket. Okay. Open and close this bracket. Go to your directory where you are saving all your files. Can you see and get file is been saved? EV underscore and is saved. Okay. Click here. Click here. copy the directory. Directory copied. Here only you are saving all this one. Go here. Again in transcript. Inside that bracket paste. Inside the bracket paste. Enter. Now if you write PWD, you see. Now tool is pointing out to which one? Tool is pointing out to which directory now? Is this same? This one and this one? Font we can't increase for transcript. Okay. This font can be this. If I zoom, then it will go outside. Okay. So at least some changes you can see now. The basic one was there, that one. With the FPGA 21 one. Now you can see that wherever I am saving the file, that has come. I just want to show you this one. Okay. Next one is plib work. Plib space work. Okay, I'll write all these steps in the notes also. Plib work. If I press enter, then what it will do? It will create a work folder. It will create a work folder in my directory. Okay. Where whenever I am going to run the simulation, the tool is going to save the internal libraries inside this work folder. Inside the library only, tool has all the keywords, syntaxes, everything is present. Tool is going to save those libraries inside this work folder. Okay. Next one is Verilog. Verilog. Test file. Verilog test bench file. What I have done? Verilog space. If I write PV, then press tab, automatically the name will come. Because in that directory, there is no other file which is starting with TV. Okay. Enter. What Verilog will do? Verilog command will do the compilation. Compilation of the test bench with the two libraries. And it will check whether there is any error in declaration. In declaration means, are all the syntaxes correct? Are we following all the rules when we are implementing this one? It will check. So till now no error. Then we see PV. PV means my test bench module. PV is my test bench module. So don't mix up. Initially everyone will mix up. There is no problem. Getting error or doing mistake is not a problem. But not doing anything, that is a problem. Okay. So first line is Verilog. Verilog, then the test bench file. Test bench file. Then vsim test bench module. You need to remember this. vsim. Now you can see the tool is running. Again, no error. vsim will do what? vsim will do the elaboration. It will elaborately check the test bench and design whether there is any logical error is there or not. Is there any logical error? Compilation done, no error. Elaboration done, no error. Then we need to add the waveform. How to add the waveform? This sim window is there. For me, it is collaborated. Okay. For someone, it can open separately. So you need to go to sim window. Okay. On this TV, right click. This TV is selected, correct? Can you see? TV is there. TV is what? Our test bench module. Test bench module. If you open TV, inside the DUT is present, correct? DUT is what? My design. DUT is my design name. Present in test bench. See? One always block is present, one initial block is present. Go to TV, right click,
It was
add
a
to,
terrorist slogan
so
first.
add web. Add web. Next thing I'll explain one thing that you need not to add this manually. So web form is also added. Can you see one web form window is been opened? But till now, nothing is there. Nothing is there. You can see A has come, B has come, Y has come, but no output. All values are X. X. After that, we need to give, go to transcript, then run hyphen all. Run space hyphen all. After Verilog also you need to give space. After vsim also you need to give space. If I press run hyphen all, the output has come. How many combinations will get? 30 combinations. Because I am repeating 30 times. Right? In between 30 you can see 0, 1. 0, 1. We are getting the output as 0. Correct? 1, 1. 1. Again 1, 1 has come. So 1. 1, 0. 0. Then search for 0, 0. 0, 0. Right? So are we getting the correct output or not? But before this one, just before running this command, whatever we have explained, can you, means on that time only, on that point only, before running this run hyphen on, where the design being checked, we can't tell at that time that my design is correct until and unless I run the command. Correct? So here you please understand the design is important as well as the test bench is important, as well as running them in the tool is also important, so that you can analyze the output whether it is working correct. Okay. Now the thing is that waveform you can also check. See, for combinational logic it is not so much important to understand the waveform or check the waveform. Okay. In Verilog, we will analyze the waveform perfectly when we are going to generate the clock. Okay. For now, you can check, like, just keep the cursor here. What is the value of A? B1. You can see A is high, B is high, so automatically Y is high. Whenever in this point, see, whenever B becomes 0, Y becomes 0. This is how you can analyze the waveform. Okay. But what I told you, for combinational circuit, analyzing waveform is not so much important. Getting the display is sufficient. Next. Now the question comes. Do we need to give these 4 commands always? If I want to run a program, do I need to write all this manually? Verilog, vsim, add web. It's until and unless we have any concept, till then we have to run like this. Now suppose how we debug a code. How we debug a code? We get error. We get error. We understand the error. Then we debug that. Simple. If you want to, I will show you error. How the error. Simple. See. I will instead of this range, I delete this. Okay. Now see, I have to start from Verilog again. I have to start from Verilog again. In Verilog. See, error has come. Error has come. What error? Illegal reference to net y. Illegal reference to net y. I have declared y as net. Net means range net. Range net means which is continuous. Where is one of the type of net that we are also going to learn. But please understand the concept of net. Net means which is continuously driven. Now I have declared y as directly output y. Output y. I didn't declare them as range. But the logic with what I have implemented, according to that logic, y should be declared as range. That's why all that 4 line number 9, 12, 15, 18. Come here. Line number 9, 12, 15, 18. To all these lines, it is giving me error. That please see the declaration of y. Please see the declaration of y. Until and unless I resume this error or resolve this error, it will not allow me to go forward. Okay. Now what I need to do? Go here, declare as range. Now suppose, let's see, I forgot to keep this semicolon. 7. Again, Verilog. Okay. What error? Please see line number 19. Near end syntax error, unexpected end, expecting semicolon. Expecting semicolon. It is not like that, oh, so many red lines, what I have done. It is not like that. You have to understand that what is the error that we are getting. Okay. What error? At line number 9, near line number 19. Syntax error, need to give. This is the way, but now please understand. Every time I get the error, suppose I got 15 to 16 error for a particular project. One by one, I am resolving. One by one. Every time I need to give Verilog command. Every time again I need to give VC. Again add web. Again run hyphen all. Is this a proper way to do the debug system? No. So for that we have a solution. What is the solution? Create a run.do file. Run. Run.do. .do is a ECL extension. ECL is one scripting is a tickle. We generally tell tickle. .do is related with that one. We are not going to learn tickle. Okay. Only we will take all those commands. Whatever commands we are giving there, we will just write here to automate that. So same, right? Verilog. The test event file name tb underscore and.b. See, tb module name, test bench module name. Next, add web, position, insert one, string, colon, slash, EV. The module name of test bench, slash, EUT, slash, star. Okay. Now you can tell, okay, sir. You can remember this line. So directly you are writing this line. But from where you get this line? Here. You can see when I add the web font. When I added the web font, that particular command has come to translate. Nothing. The same command I have written there. The same command. If you see, I'll copy this one here and paste it. You can see this is the command has come to my transcript window when I added the web font. When I added the web font to my test bench, the same command I have written. Just one addition I have given, that is duty. I want my duty signal to be also included. Here there is no duty signal extra, but going forward we'll see. Some intermediate signals will be there. If we want to add them in the waveform also, then we have to write duty. This will also come. You can see. Let's see that one. Come here. This is Verilog. No error. See. Okay. Move to. I'll close this one. Okay. See. Unlock simulator. Previously I added from here, correct? Added from TV. Now I'll select DUT. Right click, add web. Coming here. This command automatically come. I didn't give anything. Did I give this command? No, I didn't give anything. That automatically comes. Okay. Copy this one and paste it to this run.do file. Is it familiar? What I have written? Is it familiar? What has came to transcript window and what I have written? Yes. So this line is not to include duty signals. This line is to include the duty signals. Simple. Here, hash. Hash always exclude the lines. In GBIM we use double slash. In run.do file you have to use hash. Okay. Next one is run-all. All these four commands, correct? These four commands only we have used in run transcript, but manually. Now I have saved this one. Run.do file. Come to transcript. Right? Do run. Do space run.do. Enter. Vlog will automatically work. VC will automatically work. Add will automatically work. Run-on automatically work, and you will get. So what we have done? All those four commands that we have given manually, we just automate them. Why? So that the debugging situation will get easier. Okay. whenever I need to debug any error, I'll just see the error, debug that one, right? To run out. The entire code will get executed. I need not to give all the commands by myself or manually. Again, you write this one. Do run the again you can execute the whole program. How many times you want to execute? Okay. So, what are the steps to run a code in model set? The first point is that to run a code in model sim, what is the first step? To run a code in model sim, what is the first step we need to use? CD. We need to install model sim. Okay. So please install that one. After installation, if any problem is happening, we will check that in lab session. Okay. Or in my session also we can check. Initially 2 or 3 days will happen. There is no problem. Okay. So first step is please install model sim. So that, see, suppose we have lab session. After 3, 4 or 5 lab sessions, suppose someone will come and tell, sir, I didn't install model sim. So what can be done? What can be done? This should come from your side. Installation should come from your side. Next one is CD. Inside this directory, copy the directory path where files are set. Okay. How to do the copy? I have shown it. Go there, just outside click. So the entire directory will come. Just copy that one. Control C, come here, Control V. Inside the bracket. Next is Verilog. Verilog. Next, create a run.do file. Run.do file. Command is do space run.do. Space is very important for pickle because pickle is very character sensitive. Okay. So please take care of those spaces. Okay. Now we have done and get. Okay. Please try to implement or get. Any other gate, just basic gates, or get, not get, any gate. You please try to implement. Develop the test bench. Okay. Run the code in model sim. Okay. If you get error, there is no problem. Invest some 15 to 20 minutes so that you can debug the error or take it there. Code next one. Don't stop yourself at or get only. Okay. Implement and get. Again, if you are getting error, keep them. But why I am telling you this? This will be very useful for you because when you ask someone and though that error got resolved, okay, you get to know that why that error has come. Okay, so you will not do the same error again. But if you don't implement anything, only just you see, okay, this error is coming, this has been resolved, I can remember. That will not work. Okay, that will not work. Debugging is very important in your field because you are going to become a verification engineer. Verification is totally based on debugging. How to get the error? If there is no error, you have to get the error. That is the thing. Yes, that is a practical thing. It sounds funny, but that is a practical thing. Because if suppose if there is no bug in the design now, people have to create some scenario so that the public. Okay, it is normal. Okay, and it is not possible that for any design that come to the team and it is perfect. Bug will be there and debugging will be there. And debugging, from here only you will develop your debugging skills. Okay. So any confusion? Whatever I have explained till now, do you have any confusion, any question? Yeah, please. Okay, if there is no confusion, I'll end the session here for today. From the next session, we'll start implementing basic combinational logic, like half adder, how to implement half adder, full adder. Then mux, different muxes. For 2 to 3 days, we'll practice this one. Okay. Then we'll move to next one, data types. Like I'll explain that one, that how we are going to do. For this session was only for how to implement the basic code, how to run the code in models. Okay. So please go through this one, practice and remember. Okay. So I'll end the session here. Thank you everyone. Please give your attendance after that I'll end the session.
So when is the next session?
You will get to know in the group. In the group only you will get to know when will be the next session. Okay, so I'll end the session here. Thank you everyone.